Okay, this is lesson 3.5. Here's the homework. These are the answers to last night's homework. Pause it and check it. Make sure you have your appropriate labels. All right, find this page in your notes. We are talking today about similar figures, dilations, and proportions, and there's a lot of information being covered in this section. A lot. All right. The first thing, I want to talk about similar figures. Similar figures have the same shape, but are not necessarily the same size. One is either smaller or bigger than the actual. Okay. One shape and it's stretched out or shrunk down, depending. But they are proportional. Congruent angles have equal measures. They're the same measure. If two polygons are similar polygons, then corresponding angles are congruent, but the lengths of the corresponding sides are proportional. Corresponding means they are located in the same position. A dilation is a transformation in which a figure and its image are similar. The ratio of the dimensions of the new image to the dimensions of the original is called the scale factor. Scale factor. That's the ratio. All right. Rectangle A, B, C, D has side lengths of 6 and 3. Rectangle R, S, T, U has side lengths of 48 and 24. Are the rectangles similar? Well, first of all, what do we know about angles in a rectangle? They're all 90 degrees. So all the angles are definitely congruent because they said they're rectangles. So they're all 90 degrees. Let's figure out what the ratio of the sides are. Because if they are similar, there will be the same ratio. Now, you can set this up one of two ways. This first rectangle, if you do width over length, won't it be 24 over 48, width over length? What will the width, why aren't you writing, Justin? What will the width over length be for my second rectangle? Does 24 over 48 equal 3 over 6? Yes, they both reduce to 1/2. So, are these similar? Yes, they are similar. Why? Because the ratio is the same for both rectangles. Yes. Is this the short side over the long side? Did I set this one up? Short side over long side. So, which one of these is the short side? So, short side over long side, 3 over 6. Right? Because in a rectangle, to be honest, usually width is the shorter side, length is the longer side, but it really is interchangeable. But you need to make sure that you set up your ratio the same for both rectangles. I did short over long, so it would be short over long. Do you see that? All right. Now, triangles, they're going to have to tell you that they're proportional. You can't just assume that they are. Pretend that the directions said that they were proportional. So, I'm going to circle sides that correspond. What does 18 match up with over there? What does 18 match up with? What? On the other triangle. What does 14 match up with over there? X. We call those the corresponding parts. I'm not in love with the way this problem is set up because it should say that they are similar, but it doesn't. So we're going to assume. I like to do these notations. Let me tell you something. You can set these proportions up multiple ways. I could set it up this way. 4.5 over 18 is the same as, what would the other side of the proportion be? If I did 4.5 to 18, what would the other proportion be? X over 14. You know what I could also do? I could do this. How about I said, let's start with this triangle. How about I do 14 over 18 is the same as, if I did this, 14 over 18, what would be the other half of my proportion? X over 4.5. Tell me if I'm right or wrong. What if I did 18 over 14? Could I then do X over 4.5? Look what I did. 18 over 14, and then I did X over 4.5. Does that match? Does that match? Justin? What? 18 over 14 does not match X over 4.5. It does not. You're right. No. So that is not a good proportion. Could I do 18 over 4.5 and then X over 14? Look how I did that. 18 over 4.5 and then X over 14. Does that match? No, because if I start over here, 18 over 4.5, I need to start here, 14 over X. No matter how you set it up, both sides need to be the same. Do you see that? No good. Now, let's solve these proportions. X times 18 is 18x. 4.5 times 14 is 63. Divide both sides by 18. X is 3.5. Now, this looks different. But look what's going to happen. 18 times x is 18x equals 14 times 4.5 is 63. You get the same thing. As long as both sides match, you have it set up correctly. Okay. Quadrilateral ABCD has vertices. A is at negative 2, 4. Negative 2, 4. That's A. B is at 4, 4. 4, 4, B. C is at 2, negative 4. C is 2, negative 4. And D is at negative 4, negative 4. It's diluted or dilated by a scale factor of 1.5. Graph the original. I'm sorry. The origin is the center of dilation. Graph the original figure and its dilation. To find the dilation, all you're going to do is take our scale factor and multiply every one of these by that scale factor. And watch what I'm going to do. The dilation of A, so I show A with one little hash mark. That shows the dilation. So I'm going to do negative 2 times 1.5 gives me negative 3. 4 times 1.5 is 6. I'm going to take every one of these things up here, and I'm going to multiply by 1.5 because that is my scale factor. So, the dilation of B, 4 times 1.5 is 6. 4 times 1.5 is 6. C, 2 times 1.5 is 3. Negative 4 times 1.5 is negative 6. And the dilation of D. These will both be negative 6, negative 6. So, I would go over here, and I'll do this in a different color. Negative 3, 1, 2, 3, 6, 3, 6, 6, 2, 4, 6, 2, 4. C is 3, negative 6, 3. And this one will be 3, 6, 3, 6. There we go. Okay, triangle ABE, this little symbol right here is similar. Similar, I guess I can spell it right. The triangle ACD. The squiggle means they are similar. Find the missing side. Now, I'm going to separate these two out. My first triangle is going to be that. That is ABE. This side is X. How long is AB? Look at the diagram over there. How long is side AB? Correct. Because this whole length is 24, and that little chunk there is 8. So doesn't that make sense that this chunk here is 60? You might not necessarily need to redraw the two triangles, but I think for right now, it is not a bad idea. Then, my second triangle is the whole thing. So I'm going to draw that over here, and that is going to be A, C, D, and this side is 18. What is this side? Now, I'm going to do the same notation that we did in that other example. Do you guys agree that X corresponds with 18? Those two sides match each other, or correspond. What corresponds with 16? Who can give me a proportion? Because the sides are proportional. Give me a proportion that we could use to find X. Casey. Casey did this. X over 18 equals 16 over 24. Is he right? Yes, that will work. Who could give me a different proportion? 16 over X equals, so look what Ashley did. 16 over X equals 24 over 18. Is she right? Yes, she is. Both of them are. Because you're doing matching.